All right, here we go. Let's do a quick review of Unit 9 exponents. Hopefully this, before we take the test, I'm going to power through these. Feel free to pause and slow me down, but hopefully this is just kind of bringing things back for you. Make sure it's fresh before the test. Do we know what an exponent is? I hope so. The chapter is called Chapter 8 Exponents, so we got to know what an exponent is. So this is an exponent. 3 times 3 times 3 times 3 times 3 is really 3 to the what power? 1, 2, 3, 4, 5. So 3 to the 5th power. So remember we said that 3 is the base and 5 is the power or the exponent. So that's what this whole chapter is about and all the cool little rules that go with it. Sometimes we have fractions and letters in it. Remember, this is the same thing as everything on top is getting cubed. Everything on bottom gets cubed. Another way to write, man, my cubes are rough. Woo! Let's see if we can fix that. X cubed and cubed, or we can really write that as x times x if you wanted to, or 4 times 4 times 4. All the same stuff there. Really, I think the best way I would express this one is x cubed on top. 4 times 4 times 4 is 64. I think to me that's the nicest way to write that one. But they're all equal. They're all the same thing. Depending if you got to expand or whatnot. Excellent. How about this? What happens if we take a negative to an even power? Guaranteed to be positive. And really, it's going to be 3 times 3 times 3 times 3. This one is going to be just plain old 81. But technically, what does it mean? It means negative 3 times negative 3 times negative 3 times negative 3. So remember, the powers are even, they cancel out because negative times negative is positive, negative times negative is positive, so this is positive. If it's an odd power, then you end up with a negative answer. Awesome, how about this? Can I take this and condense it? Sure, 5 times 5 times 5 is what? It's 5 cubed. And I have x to the what power? X times x times x is x cubed. Y times y times y times y is y to the 4th. If you want to go ahead and multiply our number out, 5 times 5 times 5, we're looking at it's 125. So numbers you can simplify, variables, leave them alone. Nothing you can do to them, write them like that. Fantastic. What else we got in here? Then we start talking about negative exponents and zero exponents. So what does a negative exponent mean? So it means it's going to flip it to the bottom. We're going to say this is really 1 over 2 cubed. And you can think of that as 1 over 2 times 2 times 2, or you can think of it as 1 over 8. That's the same thing as 1/8. Fantastic. How about this? Could you write it using negative exponents? Sure. This is just the same thing as saying x to the negative 5th power. So that negative flips it to the bottom of the fraction. We're good to go. How about this? 0 power. Anything to the 0 power is 1. Now remember that 0 is only going to this, the base of x, so it's really 4 times 1, which is just plain old 4. So 4x to the 0 power is really just 4. Awesome. Very good. So let's go into our rules. So once we know what an exponent is, we get these rules here. So this is a rule, product rule. When I multiply, product means multiply. So when you multiply things with the same base, you add. So if I have anything with like a to the m, and I'm going to times it by a to the n, the base is a, so I'm going to say, what do I do? They have the same base, I add the exponents. So how does that look with this problem over here? You know, numbers are just numbers. The coefficients, I'm just going to multiply. 3 times 5 is 15. And, oh, I kind of picked a weird example here. I add them. So x to the 4th times x to the negative 4th, you add them, you get x to the 0. But we just did the problem. What is x to the 0? That's just like multiplying it by 1. So it's really just 15. In this case, you get plain old 15. Awesome. How about when I take something to a power? The power rule says if I take a to the m and I raise the whole thing to the nth power, what do I do here? Well, when it's a power to a power, m to the n, I actually multiply. This will be a times n. It's kind of weird. You multiply, you add the exponents. When you go power to a power, you multiply the exponents. So what does that look like in a problem over here? Well, everything gets raised to that third power, so this is really 3 to the third power. A to the negative 3 to the third is going to be multiplied, so it'll be to the negative ninth. And that's really, if it's not written, that's b to the 1. There is a 1 there, so that's like b to the third when I multiply it out. Then go ahead and simplify the numbers. What is 3 to the third? This is the most common mistake. People in the test are all going to put 9. It's not 9. It's 3 times 3 times 3, which is 27. a to the negative ninth, b to the third. And if we're saying, let's not write this with negative exponents, so what do? Well, those negative exponents got to move to the bottom, so 27 stays on top, b cubed stays on top because it's positive, but this a to the ninth has to go to the bottom. So we've got to rewrite it without the negative exponents. We only want positive exponents in our answers. Would be as rough. I don't know if that's making it better or worse there. Holy cow. I can't leave that. I'll feel bad leaving that there. Let's try this. That is B a little bit better. All right. And then finally, we've got the quotient rule here. Quotient rule, quotient means divide. So what's the division rule? If I have the base of A, raise that to the n power over base A to raise to the n power, what's the rule here? I subtract the exponent. So when you divide, you subtract. When you multiply, you add. When you power it, you multiply. Craziness. Not too bad, though, I think, once you look at the real examples over here. All I do with the numbers is just reduce them, or whatever you can. If there's anything to be done, 4/6 is actually 2/3 if you reduce it. And then this is kind of weird. You're going to say m to the fourth minus negative 2. So be careful. You're subtracting the exponents here, but because it's subtracting negatives, really like adding. So this is 2/3 m to the sixth power. So those are all our rules: product rule, power rule, quotient rule. That's 8-1, 8-2, 8-3 in a nutshell. Wrapped it up with a little scientific notation. Our scientific notation is just for using really, if we have really, really big numbers or really, really small numbers. So really, this means move the decimal 5 times. So this is 4, 3, 8. So move it 1, 2, 3, 4, 5. Fill that in with zeros. And what number am I looking at? This is 438,000. So when I have a big number, sometimes it's easier to write it scientific notation. Or, in this case, a small number. This means move the decimal 6 to the left. 1, 2, 3, 4, 5, 6. So if I put these in, I'm looking at 0.1, 2, 3, 4, 5 zeros, 2, 1, 7, 5. So now we've got this really, really, really small number. So again, scientific notation, really, really big, really, really small. So here are some other numbers. What if I give you the number? Can you make this scientific notation? Sure, you want to go 3, you want one number, then the decimal, and then you can cut off wherever the zeros are, and I'm going to say 10 to the what power? Well, decimals are normally here. I moved it 1, 2, 3, 4, 5, 6 over. So I've got this going on. I know this one's going to be small, so it's going to be a negative exponent. The reason this is negative, I mean, you're multiplying by 1 over 10 to the 6. That's why this is happening, these really small numbers with these negative exponents. So this is 3.82 times 10 to the, how many? 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. Awesome, very nice. Let's see what we got here. Let's take a look at the different rules. We can do our whole product rule, power rule, quotient rule, all that stuff. Well, I wasn't going to show all that, but that's okay. Let's take a look. Let's cover this one up for now. Yes. All right, so with scientific notation, the rules are still the same. Numbers like numbers, 2 times 3 is 6. And when I multiply, the base is still 10 in both of these. So when I multiply, add, so 8 plus negative 4 is going to give me this. Fantastic. How about this one? I have power rule, raise it to a power. Same thing. This is like saying 2 to the third. Numbers are always the same. Times 10 to, this is negative 8 times 3 is negative 24. And really, I'm not going to leave 2 to the third is really 2 times 2 times 2, which is 8 times 10, negative 24. So crazy small number here. Negative 24, if you're moving that 24 times, really, really small number there. And then last but not least, we get the quotient rule. So treat my numbers like numbers, so I end up with 12. And I'm going to times this, the base is 10, so I'm going to say negative 4 minus 6. I actually get more negative, so it's going to be to the negative 10th power. Just be careful on this. Is this scientific notation here? No, this is like a weird example. This is 12. The decimal's not in between them, so I really want 1.2. So what happens here is I had to move the decimal 1 to the left. When you move to the left, you're going to bump this up 1. Well, up 1 makes this negative 9. It makes it more positive. So technically, this is your answer, and this is what we're looking for in the test. That's your answer in scientific notation. Excellent. That's a quick review of the entire chapter. Make sure you understand the review. If you understand the review, you're going to ace the test. Excellent work. Good luck on everything. Peace out. Keep it real.
This one is for the students learning exponents. I will show you in a way so it just makes sense. When it comes upon a test, yo, don't be afraid. Listen to my rhymes and you'll be sick. The rules, they cool, don't be a fool. You just gotta listen to your teachers in school. It's time now to have some fun. If you raise it to a 0, then the answer is 1. Raise it to a 1 when the problem is a done. When you use a 2, I'll tell you what to do. Do you multiply the number by itself? You know, you just squared a number if you feel my flow. You say, excuse me, when it's a 3 or 4. I mean 5, 6, 7, or maybe something more. You just take the base, then look up high. The number is the time you need to multiply. Oh, yes I did. Somebody please tell me who the heck I is. I am Miss Curves. I hit the math up, back my work up, and chuck the
Hey, we got that base multiplying away, showing how to write it another way. You can use exponents. You miss on the base. You miss on the base. You can use
This one is for the boys trying to multiply. Got the same base, maybe different up high. Write the bases out, then count them all. Your new exponent is a total. This one is for the girls trying to work a divide. You got factors down low and some up high. You just gotta break up each group and put them in a loop. Then simplify the ones. Excuse me, we got one more rule. If there's a power of a power, don't look like a fool. I mean, sigh. Just give it a try. You take your exponents and multiply. Yes I did. Somebody please tell them who the heck I is. I am Miss Curves. I hit the math up, back my work up, and chuck
Hey,
the
we
deuce
got
up.
that base multiplying away, showing how to write it another way. You can use exponents. You miss on the base. You miss on the base. You can use
There's a negative exponent in your way. No, it can't stay. Flip it over the bar, yeah, that's the way. Hey, we got that base multiplying away. We're showing how to write it another way. Oh, it'd be like exponent. You can use that exponent.
Hey, we got that base multiplying away, showing how to write it another way. You can use exponents. You miss on the base. You miss on the base. You can use exponents. You miss.